Hello once again and welcome to another algebra lesson. This is the last section for chapter 4 that we're going to be covering, and this is called Relations and Functions, and we're in section 4-6. Today I'd like for you to be able to tell if a relation is or is not a function, and I'd also like for you to be able to find the domain and range of them given different pieces of information and to be able to write in function notation. So, the first thing that we have is a little bit of vocabulary. What is a relation in math terms, at least? A relation is a pairing of numbers in one set. A relation is a pairing of numbers in one set. Now, a relation has different elements of it. It has something called the domain. The domain is all the x values. While the range is going to be all the y values. Now, an easy way to kind of remember the difference: domain and range are alphabetical, and x and y are also alphabetical. So that could be kind of a way to help you remember which vocab piece is which. Now, we also have a special type of relation, and it's called a function. A function is a special type of relation in which each value in the domain is paired with one value in the range. So each x only has one y. Each input only has one output. So we are going to kind of express functions in multiple ways. We're going to start with a mapping diagram. So in example 1, it says, identify the domain and range in each relation. Represent the relation with a mapping diagram. Is the relation a function? So remember, domain are my x values and range are my y values. So I'm just going to underline all my x values. I have -2, 0, 4, and 5. So those are going to go in my domain oval. So I'm going to have -2, 0, 4, and 5. Then I will use a different color, so hopefully you can see it easily. I'm going to look at all my y values. I have 0.5, 2.5, 6.5, and 2.5. If you have a number repeat, then you do not write it again. You only write it once because otherwise that would be redundant. So I have 0.5, 2.5, and 6.5. I'm not going to write 2.5 again because it's already in there. So I've just separated out my x's and my y's, and now I'm going to draw arrows to connect the ones that are paired together. So the -2 is paired with the 0.5, so I'm going to draw an arrow between those two. The 0 is connected to the 2.5, so I'm going to draw an arrow from the 0 to the 2.5. The 4 is connected to the 6.5, so I'm going to draw an arrow there. And the 5 is connected to the 2.5 up here, so I'm going to do that. Next, we have to ask ourselves, is this a function? The answer is yes, because notice how each of my x values only goes to one other number. Yes, two things went to this one. That's okay. What we can't have is two things coming from one number over here. So this is yes because no x values went to more than one y. So let's look at the next example and see what we get there. We're looking at our domain and range again. So first our x values. I have 6, 4, 6, and 5. Notice how the 6 repeats, so I'm not going to write it more than once. I'm just going to write it one time. So I have 6, 4, and 5. Then I have my y values. That's 5, 3, 4, and 8, so I'm going to write those out. And now I'm going to draw my arrows connecting each number to what they correspond with according to their ordered pairs up here. So 6 goes to 5, 4 goes to 3, 6 goes to 4, and 5 goes to 8. Here, do you notice how the 6 has 2 lines coming away from it, meaning the 6 goes to the 5 and the 6 goes to the 4. That means this is not a function. It will not work. No, because the x value at 6 goes to more than one y value. All right. We have 2 more examples that are exactly like that. We're going to identify our domain. So we've got 4.2, 5, 7, and 4.2 again. So let's write those in here. I have 4.2, 5, and 7. Notice how I did not write 4.2 twice because I do not want to be redundant. I also have 1.5, 2.2, 4.8, and 0. Because those are the y values, I'm going to write the y values in the range. So I have 1.5, 2.2, 4.8, and 0. Now I'm ready to start drawing my lines connecting everything. So 4.2 goes to 1.5. 5 goes to 2.2. 7 goes to 4.8. And then it says 4.2 goes to 0. Once again, we have this 4.2 up here that is causing problems. This guy right here. This is what makes this not a function. I guess it's not necessarily wrong. That's not a great word to use, but it's not a function. So no. Because the value of x at 4.2 goes to more than one y value. 4.2 goes to both 1.5 and 0. We cannot have that if we want it to be a function. So let's look at our next example, looking at our x's. Remember, x is domain, range is y. So I've got -1, -2, 4, and 7. No repeats. So I'm going to write them all out. Then I have 1, 2, -4, and -7 for my range. None of those repeat either, so I have 1, 2, -4, -7. And I'm going to draw my line. So I have -1 to +1, -2 to +2, +4 to -4, and +7 to -7. Because all of these only went to one number, yes, this is a function. So I'm just going to write yes. And the reasoning is the same for this guy up here. I just don't want to write it again. Now, you're not always going to want to make a mapping diagram. You might be given a graph, and making a mapping diagram is not the most convenient way of figuring out if something is or is not a function. If you're given a graph, there is something called the vertical line test. So another way to decide if a relation is a function is to use the vertical line test. If a vertical line touches your graph in more than one spot, it is not a function. That is very important. So this is honestly one of my favorite shortcuts to use. The vertical line test is very helpful to just look at a graph and immediately know if it is or is not a function. So why does this work? Well, it works because when the line touches the graph in more than one place, it means an x value or an input got paired with more than one output. Remember, only one output per input. I am going to put a little burst symbol around that because that is so important. This is the whole concept of today. Is it a function or not? All right, it needs to meet this criteria. Only one output per input, or only one y per x. So let's look at some examples with graphs where we can use this vertical line test. Imagine, if you will, let me get a pencil here. There we go. Imagine, if you will, this pencil is a vertical line. And I'm passing it across the graph. And I'm asking myself, will that line touch the graph in more than one spot? For this one, no, it did not. If I were to kind of draw a couple in for you, if I draw in a vertical line right here, it only touches the graph in one spot right there. If I were to draw in another vertical line right here, it only touches in one spot right there. So this one, yes, it is a function. It passes the vertical line test. Let's look at my second example. Here, I'm passing the pencil across, looking to see, is this going to touch the graph in more than one spot? Yes, it does it the whole way. So if I were to draw that in, I don't know, put a line right through here. Notice how it touches right here and right here on the graph. It is touching this circle in two spots. That means that a x, or an x I should say, got repeated, and we don't want that. So this is no, not a function. It fails the vertical line test. So how are we going to know if something does or doesn't fail the vertical line test if all we have are coordinates? Well, we're just going to plot those coordinates and then pass an invisible vertical line through it to see if it would or wouldn't touch. So let's just graph all of these coordinates down here. It says, is the relation a function? Use the vertical line test. So that's what we're going to do. So we're going to go back 4 down, or up 2. I almost messed that up. Back 4, up 2. That's this first one. Then it's at point -3, 1, so I'm going to go back 3, up 1. Then it's at 0, -2, so that's right here. Now I'm at -4, -1, so back 4, 1, 2, 3, 4, down 1. And then at points 1, 2, so over 1, up 2. If we are to pass a vertical line through this, up and down, up and down, up and down, hopefully you notice right here, these 2 points are on top of each other, which means that this is not a function because this line passes through 2 of the coordinates at the same time, which we cannot have. For something to be a function, you can only have one output per input. So this is no, it fails the vertical line test. Let's do problem B. All you're going to do is graph your 3 coordinates. So let's do that. I have -2, 0, 0, 1, and 2, 0. Well, if I were to continue to pass invisible vertical lines through all this, like over and over and over, there would be no spot where a straight up and down line would pass through two of these points at the same time, which means, yes, this is a function. Let's keep going. I think that we can probably do just about the rest of this in one video, and then you won't have a video tomorrow. Here it says, you try. So these are exactly like what we just did. We're going to plot the coordinates, and then we are going to determine if they fail or pass the vertical line test. So the first one is 4, 2. So I'm going to go over 4 up 2. Then 1, 2 over 1 up 2, 0, 1, negative 2 up 2, and then over 3 up 3. So looking at this, if I were to pass that vertical line across my graph, will that ever go through more than one point at the same time? The answer is no, so it is a function. So yes, it is a function. Looking at the next one, though, we have some more coordinates. Let's graph them. So I have 0, 2, that's left and right none, and up 2. 1, negative 1, that's over 1, down 1. Negative 1, 4 is back 1, up 4. 0, negative 3 is left and right none, down 3. And 2, 1 is over 2, up 1. You pass your vertical line across the graph. And if you notice, right here on the axis, on the y-axis to be specific, that vertical line would pass through these 2 points at the same time. That then makes this fail the vertical line test. So this is not a function. And that's it for the vertical line test examples. Now, we have been talking about functions this whole section, so we are going to talk about something called function notation. So you have seen functions represented as equations involving x and y, such as y equals negative 3 plus x. That is a function. So below is the same equation written in function notation. So this guy right here, f of x is equal to negative 3 plus x, is the same thing as that one. That is the same problem. It is the same equation. Those two things, no real difference. The only reason we have them written differently is because we want to emphasize the fact that we are calculating a value based off of an x input. So that's why we use function notation. When you see this f with a parenthesis and then an x on the inside, you read it as f of x. And it replaces the y, which means f of x and y are both interchangeable. But keep in mind, the f is a name, it is not a variable. So this is just another way to write it. It's the same problem, but it does have its benefits. Finally, you can use other letters such as G or H. So those are the three most common letters that we use, f of x, G of x, and H of x. But of course, there could be other options. It's not like you're totally limited there, but usually we use those three letters for function notation. This is going to be very similar to what we've been doing in DMR, where you substitute in a value. So let's go ahead and look at example 3. it says the function w of x is equal to 250x, represents the number of words you can read in x minutes. How many words can you read in 8 minutes? So basically this is what it's saying. The amount of words you can read in a certain amount of minutes is equal to 250 words times that amount of minutes. That is what this whole mathematical symbol or equation means in words. I'll say it one more time. The amount of words that you can read in X amount of minutes is equal to 250 times X amount of minutes. So we're told we want to calculate for 8 minutes. It is simple as this. You take that that 8, substitute it in for X. So W of 8 is equal to 250 times 8, which is going to equal 2,000. This means in 8 minutes, you can read 2,000 words. What about 6 minutes? You do the same thing. I'm going to take this 6 and substitute it in for X. So W of 6 is equal to 250 times 6, or 1,500. So that means you can read 1,500 words, or 1,500 words, in 6 minutes. We're going on to the back page. We are almost done. It says, you have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 square feet. The function A of Q is equal to 100Q represents the area in square feet that Q quarts of paint can cover. If you use all the paint, what is the area of the trim? Here's the important parts you need to know. That's the function. It's basically telling us this. 1 quart of paint covers 100 square feet. So how many square feet could 3 quarts of paint cover? That's what we're asking ourselves. So we're going to take this 3, we're going to substitute it in for Q. That's going to be A of 3 is equal to 100 times 3, or 300. So this is letting us know if I have 3 quarts of paint, then I can cover 300 square feet of trim. We're going to do the same exact thing in example 4, except now it's just all algebraic and no word problems. So it says evaluate each function for the given values of x. And this is, once again, very similar to what we've been doing in our DMR. Evaluate means to substitute in that value and simplify. So this x right here, x equals 4, I'm going to stick it in for x in every spot. So this is going to be the function of 4 is equal to 2 times 4 plus 4 squared. Or the value of this function when x equals 4 is equal to all of this stuff. So g of 4 is equal to 8 plus 16. G of 4 is equal to 24. Let's do that again. For problem B, I have x equals negative 3. I'm going to take that negative 3 and substitute it in for x. So the value of this function at negative 3 is, that's what we're saying when we write this, the value of this function at negative 3 is, and then I'm going to say negative of negative 3 plus 17. Now if you're thinking, wait a minute, why 2 negatives? It's because there's a negative here and there's a negative here, so it's negative, negative. So they turn into positives. So h of negative 3 is equal to 20, because 3 plus 17 is 20. And there's my solution there. All I have is one more problem. And it says f of x is equal to 1/2 x plus 12 minus x squared. I'm going to take this x equals 6. I'm going to stick it into my x values. The function, or the value of the function at 6, is equal to 1/2 times 6 plus 12 minus 6 squared. All I did was take this x equals 6 and stick it in for every spot there was an x. So now I'm going to get f of 6 is equal to 3 plus 12 minus 36. And that gets me -21. And there you have it. We have introduced functions to you. We will be spending multiple days on this to make sure you're getting plenty of practice. So if you have questions, be sure to bring them to me tomorrow in class. Have a good night.